Today we'll be doing three-dimensional vectors. We'll be looking at the x, z, and the y plane, where x is I, y is j, and z is k. So we'll be doing the addition and subtraction of vectors and also the magnitude of a vector. So we'll be having the vector where vector has both magnitude and direction. We have a position vector, and let me get into what exactly do I mean by a position vector. We have a position vector and it's in the plane x, y, and z. If you realize we have I, j, and k, which we use when we have the algebraic form. So this is the y, the x, and the z line. So we have a position vector here that's a, b, and c represents x, y, and z. So k represents z, j represents y, and I represents x. So we're going to look at addition and subtraction of vectors. First, I'm going to explain the algebraic expression for A, C, and B. So just remember that I, J, and K, those three letters represents the plane X, Y, and Z. So looking at the first part for A, we have 2i, so coefficient of I is 2, that represents the x value, and the coefficient of j, that's negative 3, that represents the y value, and k, the coefficient of k is 1, and that represents z value. So for b, what we have is the coefficient of I is 5, which is for x, and the coefficient of j is negative 4, that's for y, and the coefficient of k is 3, that's for z. So for c, we have the coefficient of I is negative 1, the coefficient of j is 3, and the coefficient of k is negative 1. So we are going to do this operation where we're going to add a plus b. So we are going to write the vectors in the column vectors form. So we have a, which is 2i minus 3j plus k. So for this, we're going to take the coefficient of the letters in the algebraic form. So we have 2, negative 3, and 1. And as you can see, we have this in the column vector form. So looking at b, we need to take the coefficient 5, negative 4, and 3. And here you can see we have it in the column form. So this is the vector v. So the next step is just to add 2 plus 5. That gives us a 7. And negative 3 plus negative 4, that's negative 7. Then 1 plus 3, and that gives us 4. So this is the column vector, but we can also write it in the algebraic form where it becomes 7i minus 7j plus 4k, and that's the algebraic form. Now we're going to look at a minus c. Again, I'm going to write it in column form. So a as a column form 2, negative 3, and 1 is a coefficient of k, minus c, which is negative 1, 3, and negative 1, which is a coefficient of k. Then we're going to do the operation, which is subtraction. So 2 minus minus 1 becomes plus, so 2 plus 1, that's 3. Minus 3 minus 3, that's negative 6. And 1 minus minus 1, that's 2. So this is in the column form. We can also write it in the algebraic form where we add I, j, and k. So it becomes 3i minus 6j plus 2k. And that's it. So we have the next example, which is 4a plus c. So we're going to multiply a by 4. So we have the 4, then a as column vector 2, negative 3, and 1, plus c, which is negative 1, 3, negative 1. So multiplying a by 4, 4 to 8. 4 times negative 3, that's negative 12. 4 times 1, that's 4. Now we're going to add. So adding the two column vectors that we have here, we add across. So we have 8 plus negative 1, that's 7. Negative 12 plus 3, that's negative 9. And 4 plus negative 1, that's 3. So this is a column vector form, and this is an algebraic form where we have 7i minus 9k plus 3k. And that is it. Now let us find the magnitude of a vector. The magnitude of a vector is square root of x squared plus y squared plus z squared. Remember that when we are finding the square root of a number, it can never be negative. So calculating the magnitude, we have 2, which we square, and substitute in the formula we have x, so it's 2 squared, y is 6, so that's how we have plus 6 squared, and z is 3, so that's how we have plus 3 squared. So 2 squared is 4, 6 squared is 36, 3 squared is 9, so adding this we have 49, and the square root of 49 is 7 units, so the length of this vector is 7. Now let us look at the next example where we're going to find the magnitude of m. So again, we're going to use the same formula that we have here. So finding the magnitude of m using the coefficient of I, j, and k, we have 2, which is x, becomes 2 squared, minus 4 is the coefficient of j. As you can see, we have negative 4 squared, and 4, which is the coefficient of k that represents z, is 4 squared. So 2 squared is 4, negative 4 squared is 16, and positive 4 squared is 16. And adding it, you have 36. So the square root of 36 is 6. Now let us do the final example for this. We have the vector v that we're going to find the magnitude of. So the coefficient of I is 3 over 2, so the coefficient of j is negative 1, and the coefficient of k is square root of 11 over 2. So when we're substituting, we substitute as I've stated. You have 3 over 2 all squared. When you square that, you have 9 over 4. Squaring negative 1, it becomes positive 1, and squaring this, the square root, it cancels the square, and you square the 2, so it becomes a 4. So adding this up, you will get 6, and the root 6 units will be the magnitude of this vector. Thanks for watching, guys, and I hope you enjoy.